Hi everyone, in this video I'm going to go over VAME, and let me bring up my pointer here. VAME stands for Variational Animal Motion Embeddings, and this allows you to take your deep lab cut CSV outputs and to obtain behavior classifications such as walking, grooming, running, patterns within the behavior, and so many other things. Now this is based off of a paper that is shown up here on the screen. And the basic idea behind this is to first take the input behavioral time series data, such as the CSV output from a deep lab cut analysis, and to first process it so that you align all of your frames egocentrically. And that goes into data preparation. Now, if you're taking videos and recording videos and then running them through deep lab cut and you only have one fixed camera angle, you don't need to go through egocentric correction. But then the next step is to train a variational encoder, and in this step the VAE learns to compress high dimensionality data such as multiple body parts into low dimensional array such that it captures the underlying structures of the behaviors. So think about principal component analysis, where you're taking high dimensional, multi-dimensional data sets and converting them to for example, a two-dimensional plane so that you can see patterns between different subgroups of your behaviors. Then the next step is to take and do the motif extractions. So in this step, the trained VAE is used to extract motifs of behaviors from time series data by analyzing the latent representations that you get from this step. So here, for example, it will identify different recurring patterns as the latent space and then characterize them into specific movement types. All right, so then what are the benefits? So benefits are that this is an unsupervised learning workflow. So VAME allows for unsupervised learning, which means it can identify meaningful patterns called motifs without relying on labeled data. So that you can give it your raw CSV deep lab cut outputs, and it will cluster the behaviors into different groups, and then you can go through those groups and see which ones you want to keep or not keep. So high dimensionality data analysis. Now this approach is very powerful. The variational encoder based approach enables analysis of high dimensionality behavior time series data, which is challenging to analyze using traditional methods. And this platform provides a very easy to follow tutorial on their GitHub as well. So in multi-scale representation part, the VAME provides great representations of multi-scale behaviors, allowing for detection of patterns at different time scales, short-term versus long-term time scales. So I do encourage you to check out their GitHub repo to learn more about how you can do these things. And then lastly, robustness and variability. It handles noise and variability really well. The VAE model is robust to noise, which enables it to extract meaningful motifs, behaviors, despite potential errors and irregularities in the behavioral time series. So the workflow itself is fairly easy. We initialize a project, train a neural network, evaluate performance, segment behavior, and then quantify the output. Now, the first three parts here, you would notice that these are very similar to Deep Lab Cut, which is where this approach is heavily inspired from, and authors acknowledge that in their GitHub repo also. But this video's focus is going to be on the first two steps. So I want to get you started with downloading the VAME, getting it set up in Anaconda environment, and then starting the training process. All right, next let's navigate over to the GitHub repo. And here you're going to either download as the zip file or git clone it into one of the folders. I'm going to use the 1.1 package here and download this as zip. This is from 2022. and this I found to work really well for me. So download whichever version you want, and then open your Anaconda, and let's create an environment. So within the GitHub repo, once you extract it, there is going to be a VAME.yml file. So this YAML file is going to be used for creating this environment. There are a few things that I want to change here. For example, this Python 3.7, I want to make it specifically 3.7.7. So this seems to work for me, and this sklearn is deprecated, so we're going to switch this out for scikit-learn. So here I'm just copy pasting the sklearn. Okay. Then I'm also going to make changes to the setup.py file. Here also change the sklearn to scikit-learn. Okay, rest of this can stay the same. So those are the few changes you need to make. And then to create your environment, you have to run the conda environment create -f and then vame.yml file. Okay, please make sure that you are in the directory where your GitHub repo was extracted. So here I'm going to go ahead and activate my conda environment. And then using the setup.py, I'm going to install the VAME. So the command is python setup.py install. So once everything is finished, you should see this finished processing dependencies line pop up. So this just means that your environment is set up and we're ready to proceed. So next I'm going to utilize Visual Studio Code. And by utilizing the VS Code, this makes the integrated command workflow very easy. Now you can also utilize Spider here. I just prefer Visual Studio Code. And here I'm opening my folder in which my GitHub repo was unzipped. And from within this folder, I'm going to create a new project file. And this is going to be my Jupyter script. So within this Jupyter script, I'm going to import VAME. Now VAME is one of the folders within the GitHub repository. Here, for example, you can see that. And this contains the initialization script. There are a few things I need to change within the initialization script. They're very minor, but I'm going to show you the message that pops up if you don't change those things. So setting my environment to be VAME. You can see that up there. And before I even run my Jupyter script, I'm going to test out the import of VAME in just the command terminal. So by utilizing Python, here for example, if I type in Python and then I import VAME, and if I get an error message, that is one indication that something is wrong. Now Visual Studio Code allows me to click on these files here where the errors are. And this is one reason why I like VS Code. So here I'm going to go ahead and navigate over to this file that is giving me an error. So within this file, there's a small mistake. Instead of the period, there needs to be an underscore. Please make sure that you change this, otherwise you might get the same error. And then save this. We are ready to proceed to the next step. I'm going to go ahead and populate some of the code on my Jupyter script, and then I will walk through it one by one, showing you what I'm doing. So here, for example, I will set up my working directory, and this is just a directory in which my project is going to be created. So I have a demo repository folder that I'm going to utilize for this demo. Next, I need to create a project name. I will call it YouTube tutorial and the videos. So this is a critical part. You need to provide this as a list. And here I'm providing the path to the video. So next, I've already set up my project. So it looks like this. And this created a folder called YouTube with the date and many subfolders. I need to put my CSV files into the videos and pose estimation folder. So the next step is to convert CSV to NumPy, create a training dataset, and to start the training. And I will provide all of the code snippets in the video description below, just in case this video is a little bit too fast. Now, as I mentioned, that my primary goal was to get you set up and to get you up to training your model, which I've already shown here, and I will provide the codes down in the description. The authors of the GitHub repo have done a very nice job of explaining what each step does, which is one reason why I did not go into too many details. My primary goal was to show you how to make modifications to the YAML file and the setup file so you can get it set up properly on your computer. There are lots of little helper functions that help you make GIFs, graphs, and other things. So check out the GitHub repo. It's called VAME. And in a nutshell, it's an incredible tool for behavior analysis. So guys, that's it for this video. If you find this entertaining or educational, please support me by clicking the like on this video. If you want to see more content like this, please subscribe to this channel, and I will see you in the next one.